Good afternoon, everyone. Myself, Sirsat Sonali Sirsat in S.V.K.T College, Devale Camp, Nashik, in Physics Department. My subject is the Physics Principles and Applications and chapter number 6, Applications of Lasers. We will study the today's lecture is the applications of the lasers. First, we have already studied in previous lectures is the characteristics of laser beam, Boltzmann distribution law, population inversion, types of lasers and applications of lasers. We are studied in today's lectures is the microwave Vaughan, second is the radar and third is the pyroelectric thermometers. Is the learning objective in this sessions is the microwave Vaughan, radar and pyroelectric thermometer. First point is the microwave Vaughan. Microwave are a form of electromagnetic energy like light waves or radio waves and occupy a part of the electromagnetic spectrum. Microwaves are employed to relay long distance telephone signals, television programs and computer informations across the earth or to a satellite in a space. They are used to detecting speeding cars. Now, microwave is extensively used in satellite communications. Mobile phones, Bluetooth device, Wi-Fi systems, microwave also finds applications in remote sensing, radar detection, motion detection, radio astronomy, etc. Another important application is the microwave oven for cooking. We know that the microwave oven is used for the cooking purpose. The microwave is most familiar as the energy source for cooking food. We have studied in this lecture or in these sessions is the microwave oven for the cooking purpose, or this is the applications for the microwave oven. Principle for the microwave oven is the basic principle of microwave oven is to generate microwave radiation of appropriate frequency in the working space. The oven where the keep food, then working principle or working process for the microwave oven is the electrical energy in the form of low voltage alternating current and high voltage direct current is transformed and converted into direct current. A magnetron uses direct current and generates microwaves with a frequency of 2.45 GHz with a wavelength of 12.24 centimeters. The microwave are directed by an antenna at the top of the magnetron into a waveguide. The waveguide channels microwave to a fan-like device called a stirrer, which disperses them inside the oven cavity. The microwaves then reflect off the metal walls of the oven's interior and are absorbed by molecules in the food. Microwave have three characteristics that allow them to be used in a cooking. First characteristics is they are reflected by metals. We know that the microwave ovens is formed by the metals. Second characteristics is they pass through glass, paper, plastic and similar materials. We know that in microwave oven is the instrument or the its samples is used by the only metals, not a glass, paper or plastics. Third characteristics is they are absorbed by foods. Foods is absorbed by the microwave and then food is cooking. This is the diagram for the microwave oven. The microwave oven structure is first is the magnetrons, next is the oven chamber. In oven chambers we fill the food, Next is the control circuit, is the direct current or indirect current. Then next a transformer, and next a power supply, and the above line is the wave guide. Next point is the radar. The term radar is the abbreviation for radio detection and ranging. It is not a single. Radar is an electromagnetic system which is used for sensing, detecting and locating the objects present in the ambience. The system operated by transmitting an electromagnetic wave and detecting the reflecting signals. Principle for the radar is a short pulse of electromagnetic radiation is transmitted from a highly directional antenna. When this transmitted radiation hits a distance target, a part of the radiations reflected back and an echo pulse is picked by a receiver and the detect for the distance for the any objects for the your systems or these objects. We know that the radar is used in the aeroplanes, ships, etc. Next is the basic arrangement for this. The radar systems is the very powerful electromagnetic pulses are supplied by the microwave oscillator and are supplied to the modulator. The resulting radio frequency pulse are transmitted by the use of waveguides. These pulses are radiated by the use of waveguides and are radiated by a highly directional antenna to confine the radiation pulse in a definite range of directions. Since the same antenna is used for reception of radio echo, hence a duplexer is used. It isolated the receiving unit from strong transmitting pulses at the time of transmission to avoid the damage to switch and the receiver set in the intervals equal to the duration between pulse echoes. The received radio frequency pulses are allowed to pass through super heterodyne receiver to get video signals. In searching the surrounding surface for targets, the antenna is given a rotatory motions. This is the diagram for the radar. First is the delta T is the time pulses, you know that. Then transmitter and transmitted pulse. The aeroplane is received the aeroplane is the transmit the pulse, and next is the reflected pulse and receiver the radar system and detect the objects your aeroplanes or your systems, distance between them objects and the your planes or otherwise your whatever object, ships है, radar से aeroplanes whatever. Next is the operating characteristics for the radar. First is the choice of operating frequency. Next is the pulse duration. Third is the pulse repetition frequency. Next is the transmitted power output, and last is the maximum range. This is the characteristics for the radar. Next is the basic types of radar. These are the two types of the radar systems. First type is the primary radar. In primary radar is the primary surveillance radar. This is the PSR. The transmitter radiates signals in all the directions of which has a minimum ratio proportion of energy signals which are get reflected back from the target to the receiver. Advantages of primary radar is it requires high power to be radiated from the transmitter to guarantee the return of a signal from the target. Since only minimum portion of signal get reflected back to the receiver, reflected signal may be disrupted by noise and signal attenuation from various factors. And second advantages is it cannot provide lot of information about the target such as size and location with precise accuracy. And second type of the radar is the secondary radar. Secondary radar is also known as SSR, is the secondary surveillance radar. This is also called as identification friend or identification foe IFF system. It means that it can identify between friendly targets from the enemy targets. Its working operation is based on an active answering signal systems. After successful retrieving of the signal, the target sends the useful information in the form of code. Then the advantages of SSR over PSR means this secondary radar is the received signal is much more powerful, and second is not attenuated by any factors. The base station can get proper information about the aircraft, ships. Disadvantages for the secondary radar is the base station cannot get information from the aircraft that does not have any operating transponders and from non-cooperative aircrafts. Hence, SSR is a dependent surveillance system. Next is the uses of the radar. Radar is very sensitive instruments to find all weather conditions, the position of mountains, icebergs in a sea, shorelines, bores, metals, oil and ores. It is also useful in safe landing of aircrafts and to detect any aircraft in atmosphere even in poor visibility due to heavy fog. The uses of radar may broadly discuss as follows. Civilian uses. In civilian uses for the radar has been widely used by ship for navigation, in air traffic control. Radar monitors the air traffic radar with CGA means the ground control approach system is used to guide aircraft to a safe landing in the full weathers. The radars have equipped with altimeters to determine the height of the aircraft above the ground. Next application is the military uses. In military, the radars used for surveillance and for the control of weapons. The radars detect and locate hostile targets for the purpose of proper military action. Next application is scientific uses. Radars have been used as measuring tools in meteorologist. Radar can be used to guide space vehicles, satellites and for exploration of interplanetary space. Scientists use radar for better study of movements of animals, birds and insects. Next application is wind scatterometers. WSC application is wind scatterometers are used for accurate measurements of the radar backscatter from the ocean surface. Remote sensing and environment application. They are employed in remote sensing for detecting weather conditions of the atmosphere and tracking of planetary conditions. Next application is the law enforcement. Highway police force widely use radar to measure the vehicle speed for safety regulations. Next is the land use, forestry and agriculture applications. Data in the original mission targets major potential applications areas for ERS is the European Remote Sensing Satellite data are being used to monitor crop development and forestry changes independent of weather conditions. Other applications, ground penetrating radars are widely used by geologists for studying the position of the earth in earthquake detection. Next point is the pyroelectric thermometer. In pyroelectric thermometer is an instrument used in measuring temperature. Although the term pyrometer is generally considered to apply in instruments that measure high temperatures, only some pyrometers are designed to measure low temperature also. The amount of thermal energy or heat leaving a body, radiation and the wavelength of that radiation are functions of the temperature of the body. Next is the function of the pyroelectric sensor is to convert thermal energy into electrical energy or electrical energy. Triglycerin sulfate crystals are the most efficient pyroelectric converters, but for a long time they were quite impractical for use in sensors because of a low Curie temperature. We know the Curie temperature. Curie temperature is the temperature changes for the pressure, means the solid or liquid state to the gaseous state. It changes for the, or this temperature is used by the changes for the solid states or liquid state to the gaseous state, or the lowest temperature or the highest temperature for the materials is the changes for the liquid to the gaseous, and this point called the Curie temperature. Curie temperature is the highest temperatures. Other materials such as lithium, tantalate and pyroelectric ceramics are also used to produce pyroelectric sensors. Next is the applications for the pyroelectric materials or pyroelectric thermometers. The pyroelectric sensors are useful whenever there is change in a thermal radiation or heat flow need to measure. Example, motion detectors for the security systems and light control switches. Next application is the instant medical infrared thermometers, used laser power meters. Next is the used in non-contact temperature measurements, used in area for temperature measurement in the area where physical contact is not possible, such as moving objects, extremely hot bodies, etc. In these systems, measuring the temperature used by the pyroelectric thermometers. Next is the depending on the application, a pyroelectric sensor can be used either in a current or in a voltage mode. Next is the assignments. The first question in these sessions for the explains in a short principle of microwave oven. Second question is the explain in a short principle of radar, and third question is the explain principle of pyroelectric thermometers. Summary: we are studied today's lecture is the microwave oven, next is the radar, and last is the pyroelectric thermometers. Next recap is the, we will study the next lecture is the X-ray radiography, next is the computer tomography, means the CT scan, and last is the solar cell. Thank you.